Good morning. This is a video on importance of codes and standards for products which are for the critical applications and how to understand codes and standards and how to form different steps while executing this kind of a projects. So it is explained in the next two slides. Hi friends, this is Surendra Vaidya. I am going to talk today to you about the manufacturing etiquettes or project execution etiquettes or good practices in executing projects. This particular topic is very important for all of us, as most of our product development today is happening to certain codes or specifications or some ratings or the emblems or the certification logos which are required to be put on our products. Every person who's going to be the end user is worried about what is the safety, how this particular equipment or the product has been designed, how it has been manufactured, and how it has been certified. Having a good concept is very important, but so also the overall execution process till the time product reaches the end user or the ultimate customer. So mind to market is one of the jargon which is used by most of the management gurus, and I'm not going to elaborate the complete chain, but let's take example of any fabricated item or any item which we are designing it for aerospace or defense, or any item which we are going to use it for our machinery, appliances, or we are going to use it in chemical industry, food industry. So anywhere we are going to use the end application of this product or the service, how are we going to execute it? So as I said earlier, that there are always some code specifications, standards to which we try to manufacture or we try to design or we try to conceptualize a product and also get it into a physical hardware where we can get the benefit of having that product with us. So as you see here, what are codes? Codes are crucial for fabrication of critical equipments. Now, if you are talking about nuclear equipment, aerospace equipments, defense equipments, chemical industry equipments, they can be treated as critical equipments. It is not that the other equipments are not critical, but within the operating parameters, the service conditions, the serviceability of these, the taking a downtime on these equipments or appliances needs to be considered. We need to ensure safety, we need to ensure reliability of these products. The reliability basically comes in through the quality control, through the design safety factors, and if we are using a proven specification or a code where we have a reference of earlier products when they have undergone a similar kind of a treatment, have worked to its life cycle. The efficiency, the most important part in today's world, everything has to be efficient. It has to be energy efficient. It has to be process wise, it has to be efficient. The losses should be as low as possible. And to establish that, there has to be a minimum standard. And the minimum standard comes in by having the best practices for design, for selection of material, the fabrication processes. Specifications are something which are over and above. The standards and specifications are something which are over and above the code, and they are very specific to that particular product. A code which can be for structural fabrication, let's say a bridge, or let's say a tower, or let's say a building which is constructed out of a steel fabrication. And we also have structures at home, like we have the storage racks, we have the cupboards, we have so many other utilities like tables and chairs. They all are structurally designed. So there is a minimum code of what materials normally one can use in structural welding, and how that material strength wise its behavior, what kind of a protection is required on these structures, whether you have to give a red oxide, whether you have to do a galvanizing, whether you have to do a powder coating, which is the best method in the given environment. And then the standards will tell about very specific. If it is a chair, what kind of a comfort is required in that chair, what kind of a aesthetic value it should have in that chair, what kind of a full proofing as far as the safety is concerned in that. So these are all going to be, may not be applicable for a bridge or for a building construction, but those are required for table and chair. So like that, there is a difference between code and standard, and it is very essential for all of us to read these code and standards. At least one person in the organization must read these code standards, and whatever is applicable to the various departments, for design, for material selection, for procurement, for fabrication, for NDT, for heat treatment, for surface treatments, for painting, that must be passed on to the respective experts or respective supervisors to understand the code requirements or the standard requirements, and then decide for ourselves what are the good or the best practices I will choose to ensure that I meet the minimum requirements of codes, and also put beyond the code based on my experience or the organizational experience into it. So the codes and standards will help us in ensuring safety. The codes and standards will help us in achieving the consistency and the reliability, because all this data what we are collecting or gathering or discussing is converted into the design and the notes on the drawings, or there could be an attachment to the design documentation which will specify all the discussions what we have. And in our next slide we are going to see that as to what is the one of the recommended sequence for design to execution. Then there are certain regulatory requirements, like if you are making a boiler, then there is an Indian Boiler Regulation, IBR, or if you are making any vehicle, then there are certain norms which are given in Bharat 3, Bharat 4, now we are on Bharat 6. The C rating for our appliances, that gives what are the regulatory requirements. For example, if it is a electrical appliance, then what kind of a voltage it will be suited to. the voltage in each country may vary to some extent. It can be from 210 for a single phase to maybe 240, 250 in most of the European and Asian countries, whereas in America they follow 110 volts. So this is a regulatory requirement which comes in there. America follows 60 hertz, whereas most of the rest of the world you will see 50 hertz frequency which is used on the alternating current. Then there are certain requirements as to what material you can use and what material you cannot use, or if you have any disposal. So when the spares are going to be replaced, the parts which have a limited lifetime, then how to dispose of them. So how to design this so that you can easily remove and fix it, and the bare minimum portion of that is removed and fixed. And last, the code also looks for innovating with a strong base. That means when you are going to do any modifications, or you improve or you innovate a process, you shall write back to the code or the standards committee and inform them that this is a new alloy which gives this kind of a properties, or this is a new heat treatment which guarantees the heat treated properties, or this is a new design concept which we have brought in, which is giving more reliability, or it is giving more consistency in our product, and that requires to be incorporated in future revisions to codes and standards, so that we will get it properly documented, and also document it every time we create a new product, a new process, a new technology, or a new norm or acceptance criteria when we are going to do NDT or physical property testing. Now, what are the recommended practices? Let's go to the next slide. Now, the steps to be followed. Now, this is not the only process which can be followed. There could be variations from product to product, but in a generalized condition, when we say mind to market, the concept which is there in the designer's mind, he tries to put it down on paper, or nowadays on computer and on screen, and he tries to explain to his colleagues from various other departments as to how the product will look like, what specifications, what kind of a construction details are likely to come in this particular product. So this is called as a general assembly drawing. Now this is a very, very important step. Even though it is a general assembly drawing and not the final product, we need to really worry about it, and the team members shall have the discussions on the possible tolerances which it is going to emerge, the possible materials it is going to emerge based on the general assembly drawing, which gives the idea of designer, or what is there in his mind and how it is going to get converted into a reality. So the capabilities, and then to establish that we really have this capability, we can do some tryouts, qualifications, to validate and give back data to the designer, as if you are going to choose these materials, then these are the likely properties I can achieve in the manufacturing processes, after welding, after heat treatment, after machining, and what are the likely distortions and the tolerances I am likely to achieve. Maybe a particular surface requires a very high hardness, but we don't have that kind of a facility to harden it or machine it or grind it. Then what kind of a sequence are we going to invest? Are we going to subcontract? Are we going to vendor out these operations? And then, does vendor has the capability and understanding of our requirements? So those are required to be discussed and found out. So the first meeting happens with the manufacturing and the project management and the procurement team to understand the design concept, probable materials, probable processes, probable tolerances, probable NDT, and then each one gives his feedback or the comfort or the efforts which are required for the selected idea or a design. A similar exercise is carried out by the QA team, NDT team. They decide at what stage the inspection is best done, at what stage NDT is best done, and if there are third party or customer inspection stages, those are also identified to ensure that this is where the design has to take a pause and ensure that we conduct and satisfy customer or customer representatives or the third party at that. Yes, so we'll move further, and the next step is to have a cross-functional team to understand the flow of activities. Now, individually or in the smaller groups, it has been discussed to understand what is there with the designer's mind and how he is going to convert that into a drawing and the specifications or the notes on that. Now, each one, whatever has been understood, that is going to be talked in a cross-functional team where the entire flow of activities, the way they are going to happen, they will be putting in that sequence their own views or their own ideas as to how we are going to convert the GAD into a R0 version. To do that, we need to prepare a flow chart, flow of activities, and note here most important activity. What in the second and the third bullet we discussed was individual for that particular process or for only for that activity. Now we have not discussed in that for the previous activities output is going to be the input for the subsequent activities, and this internal customer kind of a relationship is going to exist, a supplier and a customer, between the processes which are being properly sequenced, and therefore there has to be a handshake between the two boxes or the two processes which are consecutive, and then only we will be able to really meet the tolerances. There are certain specs or tolerances are best achieved by the process itself, not by the external. So machining may have some idea to hold that particular job, and we don't require external fixture or any other constraint, whereas the machine has a special chuck, or machine has a special tool, or machine has a special feature, one more axis, wherein we can utilize this particular aspect of the machine for controlling or maintaining our dimensions. Similarly, by using different techniques in welding, or by selection of the right processes, or by selection of the right edge preparation for the welding, or by sequencing certain activities of welding and then machining and then heat treatment and then welding, we may be able to achieve the tolerances, but there each of the process owner has to clearly outline as to what he will do when the job will come to his department and how he is trying to manage the best possible results from his process or from his own. But there could be some deliberate pre-cambers or deliberate distortions or deliberate material removal or keeping it extra will be maintained based on our experience and certain data what we have discussed in second and third point based on some tryouts or based on some mock-ups. Then the design is going to sum up all the discussions what we had so far into R0 version, and with the inputs of everyone this version will get ready. But now a cross-functional team, once again all the stakeholders in execution of this particular project, they will sit and do a preliminary design review. So from general assembly drawing now we have come up to preliminary design review. Now this is a place where process failure mode analysis, that means now we have selected the processes, we have selected the material, we have listed down all the special applicable notes, and a formal design with dimensions, tolerances and all other critical data has been now specified. So while using an execution, if we can identify what can go wrong in the selected processes, then the monitoring or taking care or being ready if in case that situation occurs, how are we going to rectify or how are we going to take the further steps. Now with this we will be coming to a CDR. After PDR, after having done PFMEA, we will be doing the critical design review. It means now everything is frozen, qualifications are done, tryouts are done, achieving properties, tolerances or hardness or after heat treatment, whatever are the distortion levels or the fixtures, everything has been now frozen, and we are now ready to launch our first article. So when the first article gets produced, the inspection report of the first article gets into the CDR, the critical design review, and if there we are getting all the requirements which are meeting the specs and codes and customer expectations and the end users expectations, then the CDR is also approved. Once you have a CDR, then you can really run and further optimize this process without changing the essential and non-essential variables, and then create a PERT chart and adhere it while you are into the production mode. So this is the importance of codes, standards and the various steps to be followed. Any shortcut in this will create a havoc while execution, while the jobs or the parts or the assemblies are on the shop floor, and once the job is kicked off on the shop floor, then we cannot wait. It's very costly as it occupies the floor area, it occupies the volume, the space, the storage materials, it always in front of you. So even if you are stopped working for some reason, the reason for the stoppage keeps on bothering you, and as a result the overall efficiency comes down. So it is good to spend more time before we go to PDR, before we go to CDR, and once the CDR is approved and your PERT chart is approved, I think it is very easy for us to execute it seamless, smooth, and in a very effective, most efficient manner, and so that we can adhere to our PERT, whatever timelines we have outlined. And it also gives the interconnectivity, interdependency on each part, sub-assemblies, assemblies, and the final product. And the buffer, as you know, we keep it only at the end. All other buffers are required to be absorbed any delays by improving the processes, by deploying more resources, so that only at the end we have sufficient time or a buffer to conduct a recovery. I hope this teaser on codes, standards, specifications, and its importance and the steps to be followed is liked by you, and we can discuss this into more details in each aspect of the code as it has been specified in the earlier slide. So how it gives a criteria for design, how it gives criteria for manufacturing, then what are all the supplementary or the codes which are required to be read in conjunction with the other codes and standards, and overall how are we going to understand each code, whether it is for consumables, whether it is for machinery, whether it is for infrastructure, whether it is for manufacturing, whether it is for personal qualifications, process qualifications, facility qualifications, or instrument qualifications, or the design criterias, what formulas are we going to use, what considerations are we going to give for the external conditions and the worst conditions in which a customer or a product is likely to be handled, and then how are we going to still keep on improving our good practices in manufacturing, so that ultimately our product is safe, it delivers the intended purpose, customer gets what he wants or beyond what he wants, and we get the repeat orders or we get the futuristic orders. So let's meet and discuss it further. Thank you.